Julius Robert Oppenheimer, born in 1904, displayed remarkable intellect from a young age. His parents, Ella and Julius Oppenheimer, recognized his potential early on and nurtured his intellectual curiosity. He excelled in his studies, often surpassing his peers in subjects ranging from mathematics to literature. His teachers were astounded by his ability to grasp complex concepts with ease. He was drawn to science and the humanities, finding a unique balance between the two. His love for literature was as profound as his passion for physics, and he often spent hours reading and contemplating the works of great authors. This dual passion would shape his life, providing him with a broad perspective that would later influence his scientific and philosophical outlooks. He graduated summa cum laude from Harvard University in just 3 years, an impressive feat that highlighted his dedication and intellectual prowess. His time at Harvard was marked by intense study and a deepening interest in theoretical physics. Oppenheimer then pursued graduate studies at Cambridge University, where he worked under the tutelage of renowned physicists. His time in Cambridge was challenging, but immensely rewarding, as he delved deeper into the mysteries of the physical world. He later earned his doctorate from the University of Göttingen in Germany, a hub for theoretical physics at the time. Here he collaborated with some of the brightest minds in the field, further honing his skills and expanding his knowledge. Oppenheimer's early research focused on theoretical physics, where he explored groundbreaking ideas and theories. His work was characterized by a deep understanding of complex scientific principles and a relentless pursuit of knowledge. He made significant contributions to quantum mechanics, astrophysics, and cosmic ray theory. His brilliance was undeniable, and his peers often marveled at his ability to think abstractly and solve intricate problems. He was fluent in 6 languages, a testament to his intellectual versatility. This linguistic ability allowed him to engage with scientific literature from around the world, broadening his horizons and enriching his research. He immersed himself in Eastern philosophy, finding solace and inspiration in its teachings. This philosophical exploration added another layer to his already complex personality, influencing his worldview and ethical considerations. Oppenheimer had a complex and multifaceted personality. He was not just a scientist, but a thinker, a philosopher, and a man deeply concerned with the moral implications of his work. He was known for his intensity, charisma, and deep moral convictions. His colleagues often described him as a man of great depth, someone who could inspire and challenge those around him. These formative years laid the foundation for Oppenheimer's future endeavors. His early achievements and experiences shaped his approach to science and life, preparing him for the monumental tasks that lay ahead. He was a rising star in the scientific community, recognized for his innovative ideas and profound insights. His reputation as a brilliant physicist was well established, and he was poised to make even greater contributions. His understanding of theoretical physics would prove crucial in the years to come. The knowledge and skills he acquired during these early years would be instrumental in his later work, particularly during the tumultuous times of World War II. The world, however, was on the brink of a conflict that would forever alter the course of history. The rise of global tensions and the impending war would bring new challenges and opportunities for Oppenheimer. Oppenheimer's life, along with the fate of humankind, was about to change forever. His role in the development of the atomic bomb would place him at the center of one of the most significant and controversial scientific endeavors of the 20th century. The year 1939 marked the beginning of World War II. The world watched in horror as Europe descended into chaos. Against this backdrop of global conflict, a scientific discovery sent shockwaves through the scientific community. Nuclear fission, the process of splitting an atom to release immense energy, was achieved. This breakthrough held both promise and peril. The potential for harnessing nuclear energy was immense. Scientists realized that fission could be used to create a weapon of unprecedented destructive power. The implications were terrifying. In the wrong hands, such a weapon could lead to unimaginable devastation. The race to control this new power had begun. The United States, fearing that Nazi Germany might develop the atomic bomb first, launched the Manhattan Project in 1942. This top-secret program brought together the brightest minds in physics, engineering, and chemistry. Their mission to design and build an atomic bomb before it was too late. The Manhattan Project was an unprecedented undertaking in human history. It was a colossal effort that brought together some of the greatest minds of the 20th century. It was a race against time, driven by the fear of Nazi Germany acquiring nuclear weapons. The stakes were unimaginably high and the pressure was immense. The project was shrouded in secrecy. Every detail was classified and security was paramount to prevent any leaks to enemy forces. Thousands of scientists, engineers, and military personnel worked tirelessly at various sites across the United States. From Los Alamos to Oak Ridge, these locations became hubs of intense activity and innovation. Their common goal, to unlock the secrets of the atom and secure victory for the Allied forces. The pursuit of this goal required not just scientific acumen, but also unwavering dedication and resilience. The project's success depended on collaboration and innovation. Scientists had to think outside the box, often venturing into uncharted territories of physics and engineering. Scientists from around the world, many of them refugees from Nazi-occupied Europe, pooled their knowledge and expertise. They faced daunting challenges, from theoretical physics to practical engineering hurdles. The science of nuclear fission was still in its infancy. Researchers had to develop new techniques and technologies from scratch, often with limited resources and under tight deadlines. The engineering required to build a workable bomb was beyond anything ever attempted. It involved creating entirely new materials and machinery, pushing the boundaries of what was technically possible at the time. At the helm of this ambitious endeavor was J. Robert Oppenheimer. His vision and leadership were crucial in steering the project through its many challenges. His brilliance as a physicist and his remarkable leadership qualities made him the ideal candidate to lead the project's scientific team. Oppenheimer's ability to inspire and coordinate such a diverse group of experts was unparalleled. Oppenheimer's appointment as the scientific director of the Manhattan Project would have profound implications for both the outcome of the war and his own destiny. His role would shape the future of warfare and global politics. He would forever be known as the father of the atomic bomb. This title, while a testament to his achievements, also carried a heavy burden, as the world grappled with the moral and ethical implications of nuclear weapons. A Section 4 Oppenheimer's Crucible leading the charge at Los Alamos. Oppenheimer's leadership was pivotal to the success of the Manhattan Project. He established the project's secret laboratory in Los Alamos, New Mexico. He assembled a team of brilliant yet often eccentric scientists. He fostered an environment of intense collaboration and intellectual ferment. Oppenheimer's charisma and scientific acumen earned him the respect and admiration of his colleagues. The challenges at Los Alamos were immense. The scientists and engineers worked tirelessly, driven by the urgency of their mission. They faced setbacks and technical hurdles. They grappled with the ethical implications of their work. Oppenheimer, with his characteristic intensity and focus, guided them through these challenges. He inspired them to persevere. As the project progressed, Oppenheimer's own views on the bomb began to evolve. The sheer destructive power of the weapon they were creating weighed heavily on his conscience. He recognized the profound moral implications of unleashing such a force upon the world. The weight of the world, it seemed, rested upon his shoulders. Section 5. Trinity, the Dawn of a New Age, the Birth of a Moral Dilemma. On July 16, 1945, the world changed forever. It was a day that would be etched into the annals of history, a day that marked the beginning of a new era. In the desolate landscape of the New Mexico desert, the first atomic bomb, codenamed Trinity, was detonated. This was the culmination of years of intense research and development under the top-secret Manhattan Project. The explosion was unlike anything ever witnessed before. It was a moment of both scientific triumph and profound existential dread. A blinding flash of light illuminated the pre-dawn sky, followed by a deafening roar that shook the ground for miles. The sheer magnitude of the blast was beyond comprehension. A mushroom cloud, towering tens of thousands of feet high, rose ominously into the atmosphere. It was a sight that would become one of the most iconic and terrifying images of the 20th century. Oppenheimer, witnessing the culmination of years of work, was awestruck by the sheer power of the blast. The realization of what they had created began to sink in. He later recalled the words from the Bhagavad Gita, the Hindu scripture, flashing through his mind, "Now I am become death, the destroyer of worlds." These words encapsulated the duality of their achievement. The Trinity test marked the beginning of the atomic age, an era defined by both the promise and peril of nuclear technology. It was a time of great scientific advancement, but also of great uncertainty and fear. The success of the Trinity test brought a mix of elation and trepidation. Scientists celebrated their achievement, but they also understood the grave implications of their work. The Allied forces finally had the weapon that could end the war. The atomic bomb was seen as a means to bring about a swift conclusion to the devastating conflict. But the world now had to contend with the existence of a force capable of unimaginable destruction. The bombings of Hiroshima and Nagasaki would soon demonstrate the horrifying power of this new weapon. Oppenheimer, hailed as a hero for his role in the Manhattan Project, was also acutely aware of the burden of his creation. He understood that they had unleashed a force that could not be easily controlled. He had unleashed a force that could destroy civilization. The moral and ethical implications of their work weighed heavily on him and his colleagues. The moral and ethical dilemmas of the atomic bomb would haunt him for the rest of his days. The dawn of the atomic age was not just a scientific milestone, but a profound moral quandary that continues to resonate to this day.